Okay, so this is going to be part 3 of the second week assignment for Algebra 2 of solving equations. It's going to be number 18 through the end. Alright, so number 18 says, what is the solution set to this equation? Now, since it's multiple choice, the fastest way would be to just plug the answers in and see which ones work. In case this is a show all your work question, we're going to go ahead and do it the math way, which means we're still going to have to check our answers anyway. Okay, first thing I see is subtraction. I hate subtraction, so should you. We have fractions involved in this equation, so we need a common denominator. Trying to factor the denominators first. 3x plus 1 can't be factored, so I put in parentheses. X is a standalone. And then we'll put that one in parentheses. So my common denominator is the x that's outside of parentheses, which is very different than my 3x plus 1 that's in parentheses. So I'm going to multiply each fraction by what it needs. First fraction, we're going to multiply by x over x. Second fraction by 3x plus 1 over 3x plus 1. And the last fraction by x over x. So we end up with 2x over x 3x plus 1 equals 3x plus 1 over x 3x plus 1 and a negative 6x squared over x 3x plus 1. Now that the denominators are the same, we can drop them. And I'll put this in order. Negative 6x squared plus 3x plus 1. Get everything to one side. It's a quadratic, so we're going to set it equal to 0. 0 equals negative 6x squared plus x plus 1. I don't know about you, but I really don't like to factor when my square term's negative, so I'm going to divide everybody by negative 1. Okay. This is going to require a factor by grouping. So we got a negative 6. I think I'm going to do that off to the side over here. See, a negative 3 times 2 will add up to the negative 1 in the middle. So 6x squared minus 3x plus 2 minus 1. Make groups of 2. Pull 3x out of here. We get 2x minus 1. GCF of the second group is just 1. So we get 3x plus 1 and 2x minus 1 equal to 0. Now we set each one of those equal to 0. So x is equal to negative 1/3. And x will be equal to 1/2. Now remember, if we have fractions in the equation, we just need to make sure that none of our answers will cause a 0 in the denominator. And if I plug in a negative 1/3 into the 3x, that does make a 0. So I'm going to reject the negative 1/3. If I put a 1/2 in, I'm going to get 2.5. So my only answer is 1/2, which is choice number 3. All right, how many solutions exist for this equation? This equation is mixing up fractions with absolute values, and we have not solved out absolute value equations, as they no longer have that in curriculum. So this is one where we've got to think of another solution. Now, they aren't giving us possible answers, so we can't plug them in. They're just asking for how many solutions. So I think our best bet is to graph it. I'm going to go into y equals. I'm going to put the left side into y1, the right side into y2, and then wherever they cross, or how many ever times they cross, is how many answers we have. So for y1, remember this whole denominator needs to be in parentheses. And in y2, I have a negative. Absolute value signs, remember, are math. Move over to num1. Okay, that's your menu options. And make sure you end your parenthesis after the 2, plus 5. And I'm just going to hit graph. Wow. All right. Well, looking at my graph, see if I can sketch it for you. We have one of these, one of these, and one of these, and that's because the parabola is in the denominator. And then mine goes like, oops, it is kind of curved a little bit, and it looks to me as if it hits that curve. So I'm thinking it's 4, but if you guys know how to use your zoom feature on your calculator, I'm going to zoom in, see if I can get a closer look of the one on the right side. 1, 2, 3, it absolutely hits 4 times. Alright, number 20, solve algebraically. We have a square root in the problem, so we want to isolate that square root. So we have 3 square root of x equal to 2x minus 5. Now generally we tell you to get rid of the 3 and isolate the square root sign. You don't have to, but the people who don't tend to make a mistake. So I could actually square it now, and if I squared a 3 root x, it means I multiply it to itself, and I would get 9 and then x. 2 square roots of the same thing make that number. So I'd have a 9x, and I'd have to square the right hand side, which is the nicer number way to go. Okay. If I were to divide by 3 right now, I would have fractions, and I'd have to double distribute with the fractions, and while all that would still work, it'd be very difficult. So we're going to square both sides now. That's going to give us 9x equal to, and I have to multiply this out twice. So double distribute. And it's quadratic, so get everybody to the same side. Alright, and factor by grouping. You can do quadratic if you'd like. 4 times 25 makes 100. Well, 4 plus 25 makes 29, so I already know what my factors are. Don't have to think too hard. 4x squared minus 4x minus 25x plus 25. Groups of 2. Pull out the GCF of each group. Oops, sorry. And this one should have been a negative 1. 25 divided by negative 25 is negative 1. So I'm equal to 0. So we get 25 fourths or 1. But again, it's a radical equation, which means we have to plug them in and check those answers. And I've already used up 3 problems worth of space. I'm going to blow it up and do it up here. Alright, so 25 fourths is one of the answers we got. Well, square root of 25 is 5, square root of 4 is 2, and this is going to be 50 fourths. So I get 15 halves minus, if I simplify that, that's 25 halves. And that's going to give me negative 10 over 2, which is indeed negative 5. So 25 fourths is a good answer. I'll write it right here. Let's circle it. Our other possible answer was positive 1. So let's go fill in a positive 1. Square root of 1 is 1, so we get 3 minus 2 equal negative 5. No, so negative 1 is not an answer, it's only 25 fourths. Generally speaking, when you have square root problems where the square root's already in it, a lot of times it's very common to reject one of the answers. Kind of expect it. Okay, there's no way I'm going to have room to do all this work for 21. I'm going to have to make it small. Alright, so again, another radical equation, which means we got to isolate that radical. So first thing I'm going to do is get rid of my parentheses. And I'm going to move this x to the other side while I combine terms. So the square root of 6 minus 2x is equal to x plus 21. You've got the radical by itself, so time to square both sides. Squares and square roots cancel. I need to double distribute this. Whoop. No square root, they cancel. 6 minus 2x is equal to that. X squared plus 21x plus 21x plus 400 and something. 441. Move everything to one side because it's a quadratic. That's going to give us 0 equals x squared plus 44x plus 435. Wow, those are big numbers. Alright, so it's going to take me a while to figure out what goes into 435 and adds up to 44. So this little calculator trick, if you go into y equals and take the number you want to multiply to and divide it by x, then anything that works out nice in the table for partners and pairs will be what you need for factors. So I'm going to go do that. 435 divided by x. So I see 3, 145. That won't add up to 44. So I'm looking for two integers that will add up to 44. And I know they both have to be positive. So let's see. There we go. 29 and 15 show up in my table, which means 15 and 49. 29 did too, but I missed it. So, all right, since there's no number in front of the x squared, that means we can take the shortcut and just plug the factors in. We don't have to do grouping. So x plus 29 equals 0, x plus 15 equals 0. So we end up with negative 29 and negative 15. So now we need to check both those answers and see if they work. Alright, so 6 minus 2 times negative 29 plus negative 29 is supposed to equal 2 times negative 29 plus 15 minus 9. I'm just going to type the left side into my calculator and the right side in my calculator. So square root of 6 minus 2 times negative 29 and my parenthesis, because my square root's all done, plus negative 29, and I get negative 21. On the right side, 2 parentheses, negative 29 plus 15 minus 9, and I get negative 37. Didn't work. Making sure I typed everything in correctly. Alright, well, let's try our other answer. So we're going to reject the negative 29. I want to do it again with the negative 15. Alright, typing in the right side. Square root of 6 minus 2 times negative 15 and square root plus negative 15. I get negative 9. And then my parentheses on the right side make 0. 2 times 0 is 0, so I also get negative 9. So my only good answer to this question is x equals negative 15. Again, like I said, when you have radical equations, it's very, very common to reject one of your answers, as we just showed again. Alright, 22. Rabbit population doubles every 4 weeks. There are currently 5 rabbits in the restricted area. If t represents time in weeks, and p of t is the population of rabbits with respect to time, about how many rabbits will there be in 98 days? Alright, this is an exponential growth problem. So y equals initial amount of rabbits. There are currently 5 rabbits. They are going to double every 4 weeks. So T is time in weeks. So if it was every week, I would put a T, but it says every 4 weeks. So every 4th week means I need to take that T and divide it by 4. All right, so here's my equation. They want to know how many rabbits in 98 days. Well, I need to convert that to weeks first, so I'm going to divide it by 7 and end up with 14 weeks. So I'm going to plug in the 14. So y equals 5 times 2 to the 14 fourths. Make sure when you put that caret in your calculator, your exponent goes in parentheses. Otherwise, you'll have an order of operations error. So 5 times 2 caret parenthesis 14 divided by 4 and parenthesis, and I'm getting 56.56, so that would be 56 rabbits. All right, 23. Not sure if you got far enough into trig for this one or not, but there's a backdoor approach anyway. They give you an equation and they give you possible answers. So if you haven't learned the trig, then this is good to go. All right, so make sure your calculator's in radian mode. And, oh, sorry, not radian mode. Look at all of those are degrees. So I'm going to go change my calculator to degree. And I'm going to try them. So sine 32 n parentheses squared plus cosine, and I'm trying number 1, 32 n parentheses square, enter. And that comes out to be a 1. So my answer is number 1. And if you haven't learned it yet, the Pythagorean identity for trigonometry says sine squared of an angle plus the cosine squared of an angle equals 1, which actually you have investigated a little bit, because remember we said on a unit circle, sine, we made triangles, the horizontal piece was equivalent to cosine and the vertical piece was equivalent to the sine, because a unit circle always had a hypotenuse of 1. So if you do Pythagorean theorem with this little setup, you get this identity. Well, it should make sense that those two angles would have to be the same in order for that Pythagorean theorem to work. Oops, sorry about that. All right, number 24. Looks like we're going to get some imaginary numbers, so I'm thinking we are going to jump right to quadratic formula. X equals negative b turns that to a positive 24, plus or minus 24, negative 24 in parentheses squared, minus 4 times 18 times 87, all over 2 times 18. Nice big numbers. All right, 24 plus or minus, type everything into the square root. So square root negative 24 squared minus 4 times 18 times 87. I didn't want to do that. All right, no square root, my apologies. 24 squared minus 4 times 18 times 87. We're going to have to simplify that radical. So square root of negative 5,688 all over 36. All right, well, if you look at all the answer choices, they all have 158 inside the radical. So that tells me that I should be dividing this radical by 158. All right, so 5688 divided by 158 comes out to be 36. Now I know I have to have an I because it was negative. So 158 times 36, square root of 36 is 6. So that gives me x equals 24 plus or minus 6i square root of 158 all over 36, which we know when we have imaginary numbers, we need to separate. So I'm just going to do that right now. 24 over 36 simplifies to 2/3. And it's got to be positive, so those guys are out. And 6 over 36 is 1/6. So the answer is number 4. All right, and the last problem, number 25. Algebraically determine the values of h and k that to correctly complete the identity stated below. All right, so the polynomial on the left is supposed to equal the polynomial on the right. And I'm looking at the one on the left, and it's not looking like it's factorable. So I think I'm going to work with the side that's on the right. Now, when you do an algebraic proof or show the identity is correct, that usually means you just work on one side and you don't work on both sides. Okay, so for right now, I'm just going to concentrate on simplifying the right and making it a straight polynomial. So I'm going to double distribute this and get 2x cubed plus hx squared plus 3x. And then I'm going to distribute the negative 4, negative 8x squared, negative 4hx, and negative 12. And then we have this plus k on the outside. All right, so that gives me 2x cubed plus hx squared minus 8x squared plus 3x minus 4hx minus 12 plus k. And that's all supposed to equal this over here. Well, it said algebraically determine the values, so I'm sort of solving for them. But what I notice is that I have a 2x squared or 2x cubed on both sides. So these guys are already the same, so I am not going to focus on those right now. Okay, my x squared terms are supposed to make a negative 10. So hx squared minus 8x squared is supposed to equal a negative 10x squared. All right. And then my 11x is supposed to be equal to these guys, 3x minus 4hx. And then the last piece, my constant term, I'm going to write that on the left, the negative 7 is equal to the negative 12 plus k. Well, the easiest one to solve for now is the k. So I'm going to add 12 to both sides. So k is 5. Now we got to focus on the h's. Now, I should be able to drop the x's out of both of these because everybody has an x squared term, so that doesn't affect it. So all I'm really worried about is that h minus 8 has to equal a negative 10. So when I add 8 to both sides, that says h is equal to negative 2. Well, I want to make sure that it's the same thing over here. So if I eliminate the x's from all of them and concentrate on that the 11 is equivalent to 4 minus the h, or sorry, 3 minus the 4h, if I plug that negative 2 in, it better be the same. Sure enough, it is. So my k is 5, my h is negative 2, and this is the end of week 2, solving equations for Algebra 2.